In this video, we're going to learn about how to distinguish physical from chemical change. Walter White, the great chemist, once said that chemistry is the science of change. So we're really going to have to understand change before we move on in this class. So let's say that you have an observable change. Let's ask, has the substance changed in composition? If the answer to this question is yes, then a chemical change has occurred. If the answer is no, then you're looking at a physical change. So, for example, if you shred some paper or chop some wood, the paper's still the paper, the wood's still the wood. They haven't changed in composition, they just changed in shape, size, and so on. These are examples of physical change. Um, if we, say, have a phase change occur, such as melting ice or boiling water, we're making some change that still does not change the composition of the substance. Ice, water, and steam are all H2O, 100%. All that's happening during phase change is a change in the arrangement of the molecules. But what if? What if we have mixing of substances together? Sometimes when you mix two substances together, they react, and you have a chemical change. Sometimes you mix them together and they don't react, and you have a physical change. A couple examples of physical change would be mixing sand with water and dissolving sugar with water. But how do we know that they're physical and not chemical change? Well, the answer is if you can separate these substances physically using physical means, then it means that no chemical change has occurred. If I have a mixture of, say, Skittles or M&Ms and I separate them out one by one mechanically, I can change them so that they're separated by color, and that would be physically changing them using a physical separation. You need a little bit more technique when it comes to separating a mixture of sand and water or sugar and water. But to do that, you might, for example, heat the mixtures and cause the water to evaporate, leaving the sand or the sugar behind from those mixtures. On the other hand, there's chemical change. And examples of chemical change including iron rusting, burning wood, digesting food, cooking an egg, baking a cake, electroplating. There's a whole bunch listed here. But what's different? How do we know? Well, there are some really good indicators of chemical change, and all of those previous examples have one of these. At least. So, a change in color would indicate chemical change, as in, for example, rusting. You start off with, say, iron and end up with iron oxide on the surface, and that's why there's a color change. Another example is if you change the energy, the internal energy in a substance, which could be indicated by an absorbance or release of heat or light, as in the case with combustion, burning, that releases both heat and light. Another example is the formation of bubbles, a gas. And another is an example of formation of a precipitate. This is a little bit tricky to tell here, but we had dropped into a solution, we dropped another solution, and you can see this yellow stuff here. This is actually a solid. Precipitate is a solid. It's just, in this case, it's a very finely powdered solid, so it can be a little bit difficult to tell. But these indicators of chemical change work pretty well. There are definitely exceptions to all, and we'll probably cover them at different times during the year. But these are a good rule of thumb to go by. So I hope this video has been helpful. Please feel free to leave any questions or comments in the comment section below, and thanks for watching.